For a reaction to occur, reactant particles must first collide. Since particles are in continuous motion, many collisions occur between them. However, not all collisions can result in a reaction between the particles because they do not have enough energy or incorrect orientation when they collide. We assume that 100% by the mass calcium carbonate in the eggshells. Thus, 2.5 grams of eggshell will contain 2.5 grams of calcium. The amount of calcium carbonate we will need to use is 0.02498 mole. Also, we assume that the vinegar contains 5% of acetic acid. Thus, 1 dl of vinegar contains 50 cm3 of acetic acid. Based on our research, we found the density of acetic acid is 1.05 gram per cm3, and we got the concentration of acetic acid is 0.8750 mole per dm3. As the ratio between the calcium carbonate and acetic acid is 1 to 2, hence we require 0.04995 mole of acetic acid, which is also 57.1 cm3 of it. Since the minimum volume of acetic acid we need is 57.1 cm3, then we'll be using 75 cm3 acetic acid during experiment to ensure the complete reaction. We decided to use temperature for our first factor affecting the rate of particles colliding. Conducting ample research, we reached the conclusion that the temperature in Uttar Pradesh, India is generally higher on average annually with a temperature of 40 degrees Celsius, while Rome, Italy has an average of 30 degrees Celsius annually. Before we started our experiment, we made two assumptions. One was the absence of humidity in the air, and the other was the concentration of acid rain remaining the same. Since the dependent variable is the rate of corrosion, this means that the temperature is the independent variable. By assuming that humidity is absent in the air, the temperature of the surrounding would not be affected with a different level of humidity in both areas, and the experiment would be fair as the only variable change would be the temperature. For the concentration of acid rain, we chose to rule out the possibility of human activities and natural environment that may cause the concentration of acid to rise or drop. This also ensures a fair experiment as only one variable is changed. These are the apparatus used in our setup. For our procedure, we first weigh 25 grams of eggshells with an electronic balance before pouring into a 250 cm3 conical flask. We set up the water replacement apparatus used for collecting gas during experiments. Afterwards, we read the initial reading of water level in a measuring cylinder. Next, we measure 150 cm3 of 0.3755 mole of acetic acid at 30 degrees Celsius. Pour it into the conical flask containing 25 grams of eggshell before sealing the conical flask to the valve immediately. Using a stopwatch every minute to 3 minutes, we record the reading of the water level in the measuring cylinder. We are then able to calculate the amount of gas produced by subtracting the initial reading from the final reading. These steps we repeated for the same setup except the temperature of the vinegar will be 40 degrees Celsius instead of 30 degrees Celsius, as 40 degrees Celsius represents the temperature of the acid rain in India. Our data is as obtained. We use the graph to easily compare the amount of gas produced by the two different setups. The line graph shows the reaction rate of 40 degrees Celsius acid being faster than 30 degrees Celsius. In the beginning, 0.80 cm3 of carbon dioxide was produced with 40 degrees Celsius vinegar until 60 seconds. 1.20 cm3 of carbon dioxide was produced at 120 seconds, and 1.30 cm3 of carbon dioxide was produced at 180 seconds. The average rate of carbon dioxide produced was getting slower and will stop after a period of time. The conclusion is that the collected data shows that the acetic acid with high temperature produced the gas faster than the ones with lower temperature. Therefore, acetic acid with high temperature has faster rate of reaction with limestone. This can be further explained with particles collision theory. As seen currently, the particles are colliding between one another at a very fast speed. Calcium ions do not react with CH3COO- ions and their spectator ions. Two hydrogen atoms will effectively collide with a carbonate atom. They react together to form H2CO3, which eventually forms H2O and CO2 gas, which dissolves into the air. However, when the temperature of the acid increases, the average kinetic energy of the reactant particles increases. This means that the particles move faster, and the collision between reactant particles not only increases, but the frequency of effective collisions also increases, which explains why two H2CO3 and two calcium ions were separated from the structure. The two H2CO3 molecules will form H2O molecules and CO2 gas, which will dissolve into the air.
Acid rain is caused by a chemical reaction that begins when compounds like sulfur dioxide and nitrogen oxides are released into the air. These substances can rise very high into the atmosphere, where they mix and react with water, oxygen, and other chemicals to form more acidic pollutants known as acid rain. In Rome, Italy, more people travel by car or scooter, contributing to long traffic delays and poor air quality. These vehicles release pollutants and cause a lot of carbon dioxide and nitrogen oxide content in the air in Rome, which leads to high concentration of acid rain. In India, the air quality around the iconic Taj Mahal has stabilized. Also, State Tourism Department claimed that yearly average concentration of sulfur dioxide and nitrogen dioxide in the area is steady and within the notified ambient air quality standards. First, measure 75 cm3 of 0.875 molar acetic acid by using 250 cm3 beaker and add it into a 100 cm3 of conical flask. Next, set up the entire water replacement apparatus to be used in collecting gas during the experiment. Record the initial reading of water level in gas jar as RI. Next, wet 2.5 grams of chicken eggshells by using an electron imbalance and pour it into the conical flask containing the acetic acid. Then cover the mouth immediately with the rubber tubing. 3 minutes reaction will be taken as T by using an electronic stopwatch. Next, record the water level reading in gas jar after every 60 seconds as RF. Calculate the gas collector after every 60 seconds by the formula RF minus RI. Draw an amount of gas collected against timeline graph and draw a straight line between 2 points to calculate the average rate of reaction by using the formula RF minus RI over TF minus TI. Next, prepare a dilute acetic acid by pouring 37.5 cm3 of acetic acid into 37.5 cm3 of water in the 250 cm3 beaker to form 75 cm3 of dilute acetic acid. Lastly, repeat step from setting up the entire water displacement apparatus onwards till the end. This table shows all the data we collected from different acidity of vinegar during the experiment. The line graph shows that the reaction rate of pH 2 acid is faster than that of pH 3 vinegar. At the beginning, 0.3 cm3 of carbon dioxide was produced with pH 3 vinegar until 60 seconds, 0.5 cm3 of carbon dioxide was produced at 120 seconds, and 0.3 cm3 was produced after 60 seconds. This data shows that the average rate of carbon dioxide produced was getting slower and will stop after a period of time. Based on the data collected, we conclude that the acetic acid with higher acidity produces the gas faster. Therefore, acetic acid with higher acidity has faster rate of reaction with the limestone. This animation shows more particles present in the concentrated vinegar. When collision occurs, the particles in the concentrated vinegar will have higher collision frequency, resulting in more frequency of effective collision causes reaction to occur. Therefore, the concentrated vinegar will have faster reaction rate than the diluted vinegar. Based on the data collected, we found that the rate of limestone corrosion is faster when it is reacted with higher temperature and lower acidity of acetic acid. Also, the temperature is affecting more than the acidity of rain on the rate of limestone corrosion. Therefore, we conclude that Taj Mahal in India has higher rate of corrosion than the Colosseum, as India has higher temperature in atmosphere.